All right, welcome to another math video. Um, this time we're talking about applications of surface area questions. The first example we're going to go through, George wants to construct 12 open boxes. That is a very important 12 open boxes like the one shown below. How much cardboard will he need to construct his boxes? Well, let's see. Okay, if they're open boxes, that means they've got the four walls and a bottom, but they do not have a top. This is where it's really fundamentally important that we do not just look at the equations on your formula sheet. It's much better to focus on, okay, what are all of the surfaces of my object? What are they actually? Because what's going to happen is we've got a bottom on here, okay? So that's going to be surface area number one is going to be on the bottom. And then we've got a side and we've got a front. Now the front and the back are both the same. The right side and the left side are going to be both the same. And there's going to be one bottom. So the surface area of this object is going to be surface area number one. So area number one plus 2 area 2 plus 2 area 3. There's a front, there's a back, so 2 area 3s. There's a side and a side. There's 2 area 2s, and there's only 1 area 1. So let's try this out. Area number 1 looks like it's 30 centimeters by 10 centimeters. So 30 by, 10 plus 2. Area 2 is 10 by 10. So 10 by 10 plus 2. And area 3 looks like it's 30 by 10. So 30 by 10. Okay, no problem. So 30 by 10 is 300. 10 by 10 is 100 times 2 is 200. And 30 times 10 is 300 times 2 is 600. Perfect. So now we just have to add up the surface areas of all of these objects. 300 plus 200 is 500 plus 600 is 1100 square centimeters. Perfect. Now, remember, this was not one box. He wanted to make 12 boxes. So the total surface area, is going to be 12 boxes at 1100 square centimeters each. So if we go 11 times 12, we should get 132. So 13,200 square centimeters. George needs 13,200 square centimeters of cardboard if he wants to be able to construct 12 open boxes like the one shown below. Let's try another one. So we've got a can has a diameter of 6.6 centimeters. So all the way across the top is 6.6 centimeters. You should immediately notice that that's not normally what they give us, the diameter. We're going to need to find the radius of this. And we've got a height of 12.1 centimeters. Determine the amount of paper required to make the label of the can. The label of the can. Where does the label of a can go? Does it go on the top? No. Does it go on the bottom? No. It goes on the outside. So when we look at our formula for the surface area of a cylinder, it's 2 pi r squared plus 2 pi r h. 2 pi r h. We don't care about this because that's referring to the top and the bottom of that pop can, or the top and the bottom of that cylinder. We don't care about the 2 pi r squared. All we care about is the 2 pi r h. Now, let's try and figure out, okay, 2 pi r. Well, what's the radius of this thing? I'll just draw a circle. If the diameter of this is 6.6 centimeters, then that means the radius of this has to be 3.3 because it has to be half of what the diameter is. So our radius is actually 3.3 centimeters, and our height looks like it's 12.1 centimeters. So if I plug all of this into my calculator, 2 pi r h, I should get, we're going to round to the nearest tenth, I should get 250.9 square centimeters. So that's how much paper is required to make the label of this particular can. Let's try our last application question. Sam has been asked to paint the walls and ceiling of a small storage room that measures 5 by 4 by 2. A window in the room measures 0.8 by 0.5 meters. The floor is tiled and will not be painted. So let's draw a picture of this. Okay. So we've got a room. This is our room. It's 5 by 4 meters and it's 2 meters tall. We're not going to be painting the floor, so we don't really care about the floor. Nobody cares about the floor. But what we do care about is we care about the ceiling, we care about the sides and the other sides. And one last little bit of information here is that there's a window in the room that measures 0.8 by 0.5. So there's a window in here that's 0.8 by 0.5, 0.8 meters by 0.5 meters. And that's not going to get painted either. So there's two surfaces that, we could think about. Either we could calculate the total surface area and then we could subtract them, or we could just calculate the surface area of the areas that are presented and subtract the window. It's totally up to us here. So let's try this out. The surface area is going to be, it's going to be the two side walls. So we'll call this area number 1, and it's going to be the area of the roof. So it's going to be area number 2, and then it's going to be the front. That's area number 3. So we're going to have 2 area 1s plus only 1 area 2 plus 2 area 3s, and then we got to subtract the area of the window. That's what we have to do. Okay, what is area number 1? Area number 1 is 4 by 2. So 2, and it measures 4 by 2. What is area number 2? Area number 2 is the ceiling, and it measures 5 in length and 4 in depth. So 5 by 4 meters. Area number 3 is the front, so it's 5 by 2, and there's 2 of them. So 2, 5 by 2. And then we have to subtract the area of the window, and that's 0.8 by 0.5. So if we calculate all of this is going to be 16 plus 20 plus 20, and then we're going to subtract 0.8 times 0.5, 0.4. So 16 plus 20 plus 20 is 56. 56 minus 0.4 is 55.6. So the total surface area is 55.6 square meters. Perfect. And the last part of the question, if 1 can of paint covers 8 square meters, how many whole cans of paint are needed? So we can't buy half a can of paint. As soon as you need a little bit more paint, you got to buy a whole other can. So we're going to have to round up to the nearest whole can. So if our surface area is 55.6 square meters, and it costs one can of paint will cover 8 square meters. What we're going to do is we're going to take 55.6 and we're going to divide it by 8. And so how many cans of paint? We need 6.95 cans of paint. Paint cans, or because we have to round up, we need 7 cans of paint. Perfect.